So we are covering 9.4.5 today, which is about the t-test and running the hypothesis test for T. I'm going to start the class actually by writing out notes with you about the t-test, things that we have kind of already gone over before, but to make sure that you can see it more clearly. Then I'm going to be alternating back and forth between PowerPoint and the calculator and written notes so you can see things. And then I'm going to have you practice some today as well. We do have class tomorrow, and then we don't have class the rest of the week. And then when we come back, we will have 2 weeks of class, and then you're done with your semester. Okay, with all of your classes, not just mine. So everything ends, well, the Thursday is December 9th. You'll be taking your final test. We do have one more project that's going to be happening. We're going to start that afterwards. Okay. Yeah, so I haven't put in the homework yet that was due before. And I will look, I'm gonna write down the note. So Abby, the handwritten notes weren't up there. I think I put those up, but if I didn't put up the notes from the 7th, I will try and make sure that I put those up today, okay? I'll just double check.
I meant the notes from today, sorry.
Oh, yeah, I'll make sure that I write them up there. Yes, okay, yes, of course, sorry. I thought you meant from before. I was like, oh no. 11:22. Okay, so we are not reinventing the wheel. We are just going to have a different formula today with the t-test. So let me share this and we'll start to write in everything. Can everybody see this okay? And it looks like it's auto zoomed. Let me leave that straight and adjust this. There we go. T-test. Okay. When sample standard deviation or just a set of data. Same rules apply for this that applied for the confidence intervals, so that hasn't changed. And the first step of this is to write HO and HA. We are still working with mu, okay? And our null is still equal to. So that hasn't changed. Okay. Step 2, and this is by hand. Okay, we're going to write out the by hand first, and then I'm going to have you write out the by calculator. So by hand, T equals sample mean minus hypothesized mean over the sample standard deviation, which is then over the square root of n. And I'm going to label these. So this is sample mean. This is hypothesis from the hypothesis. This right here is sample standard deviation. And then that guy right there is sample size. We've seen all of these. This gives us our t-test statistic. So it's 9.4.5 is the section. Now, once I have my test statistic, when we were doing the z-test, we would then go to the normal CDF, okay? But since we're doing a t-test, then we go to TCDF, which is lower, upper degrees of freedom. Oh, sure. Let me see if I can expand it more so you can see everything. That's the only thing you're missing up at the top. Degrees of freedom we've talked about before. Degrees of freedom is n minus 1. I'll give people a second to catch up with me and write that down. Now, the only thing that we need to know about TCDF, okay, if the T is negative, okay, then we say -1 e to the 99 t degrees of freedom. Likewise, if t is positive, then we do t as the lower, 1 e to the 99 is the upper degrees of freedom. And your corresponding HAs for this, HA would be mu is less than, and this one would be HA mu is greater than. And we're missing one. If the HA of mu not equal to, we take the p-value and multiply times 2. Let me actually write that out, times 2. And we're going to do a problem that's like that so you can see it. And then the last step is step 3. We compare the p-value and the significance level. Okay. And we've gone into this. I'm going to write some more out with this, but just the quick review. If the p-value is less than the significance level, then we reject HO. There is sufficient evidence. And we've written this over and over and over again, so I'm just writing it a really small, brief synopsis of it because I don't want to write everything out, okay? And then if the p-value is greater than the significance level, we fail to reject HO. There is not sufficient evidence. No. Does anybody need more time? Okay, now we're gonna write out the ones for by calculator. Okay. By calculator. So we go to stat. Tests. T-test. And there's two different ones. There's stats. And there's data. Actually, I'm gonna write them backwards, sorry. I'm gonna write them how you would see them in the calculator. Okay, so let me reverse those, sorry. I don't want to crisscross it, okay? So if it's data, enter data into L1. That should be your first thing. And then you'll have mu0 or mu naught. This is from the hypothesis. You'll have the list, which should be L1. You'll have the mu, which could be not equal to, it could be less than or greater than. And this comes from HA. Whatever direction your HA is the direction that should be. On the other side, if you have stats, you have a mu naught, which again is from the hypothesis. You have a sample mean. You have an SX, which is sample standard deviation. You have an N, which is sample size. And again, you have your different options for mu, not equal to, less than, or greater than. And again, that comes from HA. So it's the same process. This will give you T and P. Okay, ready to delve into a problem and try it out? Okay. So if you're following along with the slides, here is the first example. We have seen this before, so this is a repeat problem, but it's good for us to now focus on the math of it. So HO in this case, we have the Bureau of Labor Statistics reported that in May 2009, the mean annual earnings of all family practitioners in the United States was 168,550. A random sample of 55 family practitioners in Missouri that month had mean earnings of 154,590 with a standard deviation of 42,750. Do the data provide sufficient evidence to conclude that the mean salary for family practitioners in Missouri is less than the the national average? Use a alpha of 0.05 level of significance. In this, we are talking about mean. So our HO and HA are both going to have our mu, our population mean. We are equal for the HO. What is it equal to?
The HO will be 168,550.
That is exactly correct. And I see it came in the chat. Thank you.
I'll be back.
Okay, so it's equal to 168,550 because that was the United States, plus it is not from the sample. Okay, we can't use the sample in our hypothesis. Now, should we have a less than, a greater than, or not equal to in the HA?
Less than.
Less than. So it should be like this, which is a left tail. Okay. Now we have our formula. T equals sample mean minus the hypothesized mean all over the sample standard deviation, which is then over the square root of n. What is our sample mean?
154,590.
Perfect. 154,590. Our hypothesized one is 168,550. I pull it down from the hypothesis. What is our sample standard deviation?
42,750.
Let's make that look like it too. 42,750. What is our sample size?
55.
55. Now I could type this whole thing into the calculator just how they have it written. Okay, but I have to put parentheses around the top. I'm trying to, instead of making the symbol, it's easier just to draw it. Okay, and what do you get for your answer for that?
T will be negative 2.41.
Anybody got anything different? And now we're going to take this value and I want to carry it out just a little bit further. So can you give it to me to 3 decimal places, please?
Yeah, I got something different.
Yeah, I don't think it's a 1 at the end.
I have
Okay.
negative 2,421.
Yes, -4. Yes, so I might have misheard. I'm sorry if I misheard that when you're saying it. Negative 2.4218. Is that what you get if we carry it out to 4 decimal places?
Yes.
Okay, perfect. Sorry. Now it's a negative, so we do T, C, D, F,
I'm back.
right? Thank you. Which we do the lower, which is -1 E to 99, -2.4218. And then we have to put the degrees of freedom in this time. So instead of the 55, we're going to put 54. We're going to do 1 less than it to get our answer. And the TCDF is at the same place you would find the normal CDF. So you do second VARS. And then you'll see the TCDF. And when you plug that in, what do we get?
I got 0.
I got 0 too.
I got 0.0094.
Yeah, so 009. Those that got 0, were you using an app or the graphing calculator?
The graphing calculator.
Okay, so let me pull that up. We're gonna be moving to that anyways too, so I'm gonna have both of them together. So if I do second VARS, TCDF, -1 to the 99, negative, all right, that does not look like. There you go, negative 2.4218. Degrees of freedom of 54. And paste. You're not getting that on the graphing calculator?
Let me try it again.
Okay.
Yeah, mine's just say 0.
Still saying 0. Huh. Can you go to your mode and see if it looks like this? Do you have it on float,
I have it on normal.
normal, and is the one below it on float, or is it on like a certain number of decimals?
No, it say float after that.
Okay, well, I'll try and figure it out at the end of class and see if we can figure it out, because you're gonna, let's see if when we do the test, if you're getting the same values that we're getting, okay?
Okay. Okay.
Okay. So we have 0.009 for our p-value. What are we gonna compare that to?
The significance level.
Yeah, the significance level. And we are less than it, right? So we reject HO. There is sufficient evidence to state that. I'm gonna write it up top so we have it, okay? Sorry, I ran out of room on here. So we reject HO. There is sufficient to state less than national average. Okay. Let me see if I can move that there. That's better, right? Put it where it needs to be. Now, if I was using the calculator, okay, hopefully we can see this information to the side of it, right? But let's go to stat and go to tests and go to the t-test. Okay, do we have data that we're entering in?
No,
No. So we go to stats. What was our hypothesized mean?
168,550.
50. What was our sample?
154,590.
Okay. And what was our sample standard deviation?
42750.
And our sample size.
55.
And now remember, we need to make this directional look exactly the same as our HA, and our HA has it less than. And I'm gonna hit calculate because I know that some people's apps don't do the draw, so I'll calculate so you can see. If you calculate, we get a T of negative 2.4217, which is what we got before. And we get a p-value of 0.009. So Carnisha, I think it was you that didn't have, you had 0. Is it showing up the 0.009 on the t-test?
Yes, it's showing up that way on here.
Okay, perfect. Okay, then I'm not so concerned about the TCDF because you don't have to do it by hand. I'm just showing you how to do it by hand for the first ones. And then after that, you're gonna be using the calculator.
Okay.
Okay. And then it shows you your sample mean, sample standard deviation, and your sample size. So the test does exactly what we did by hand, just a lot faster, right? Any questions so far? Okay, let's move to the next problem. Which is, I'm gonna actually skip you to number 4, example 4, if you're following along with the PowerPoint. Okay, so number 4, watching TV. In 2008, the General Social Survey asked a sample of 1,324 people how much time they spend watching TV each day. The mean number of hours was 2.98 with a standard deviation of 2.66. A sociologist claims that people watch a mean of 3 hours of TV per day. Did the data provide sufficient evidence to disprove the claim? Use a significance level of 0.01. Do we see population standard deviation anywhere in here? No, we don't. So we have to do a t-test for this, okay? If we had it, we would have been able to do it otherwise. So our HO is mu. Our HA is again mu, because we're dealing with mean. It's equal. What is it equal to for the null?
$2.98.
So I can see why you would think 2.98 because it's on there, but the 2.98 comes from the sample. So we can't use that in our hypothesis.
3.
3. Okay, because the sociologist claims that they watch a mean of 3 hours of TV per day. Do the data provide sufficient evidence to disprove the claim? Okay, and the 3 didn't come from it. So I'm going to put 3 again here in the alternate. And what's our symbol? Is it less than, greater than, or not equal to?
Not equal to.
Not equal to, because no direction is identified. It doesn't say greater than, it doesn't say less than, it doesn't say above or below, or just wants to know if we can disprove the claim. We're going to run a t-test. So t equals the sample mean. This is the last one I'm going to do by hand, okay? Over the hypothesize, minus the hypothesis mean, over the sample standard deviation, which is then over the square root of n. So we already heard that 2.98 is our sample mean. Our hypothesized is 3. What is our sample standard deviation?
2.66.
Yes, 2.66. What is our sample size?
1324.
Yeah, a lot of people that they asked, right? Okay, if I enter that all into my calculator, remember, put parentheses around the top and parentheses around the bottom. What do we get for our answer?
-0.2.
Yeah,
No,
27.
27358.
358, perfect, so it's 36, right? Negative 0.2736.
Yeah.
Okay. Now we have to take this value, which is our test statistic, and we have to put it into TCDF. Okay, if you remember, look back at our notes, this is negative, so it goes into the second spot. Negative 1e to the 99 is our lower. Negative 0.2736 is our upper. What's our degrees of freedom on this?
Um,
1, 3, 2, 3.
one-
Yeah, 1, 3, 2, 3. 'Cause that's our degrees of freedom. When we compute this, what do we get?
Point
0.78.
29221.
Yeah, 3922. Now, be careful, okay? Because this was a two-tailed test, right?
Mhm.
Actually, I'm gonna erase that. I don't want that to be around there. I'm gonna highlight it, okay? This is a two-tailed test, right? So what do I have to do with this answer over here?
Multiply by 2.
To multiply it by 2, okay? To get 0.7844. Okay, and the reason I multiply it times 2 is I will show you a little visual of it, okay? What's happening with this is when I run this TCDF, right? It actually gave me the value right here to be 0.3922. But it's a two-tailed test, which means that over here on the other side, okay, is the exact same p-value just for the top. So that's why I have to multiply times 2. Because the negative 0.2736, right, has, sorry, it's actually bigger than that. It has a 0.2736 at the top, but it's exactly the same. So there's a positive and a negative. And if I put in 0.27361e to the 99 with the same degrees of freedom, it's going to give me the same exact p-value. So I just take the value that I found and I multiply it times 2. It's a much simpler and faster process.
Okay.
Now that I have my p-value of 0.7844, what are we comparing it to?
Zero 0.01.
Yeah. And is it less than, greater than, or equal to?
Greater than.
Greater
It is
than.
It is super greater than, okay? Since it's greater, what is our conclusion?
Fail to reject.
Fail to reject. Is not sufficient evidence to say or to state the mean is different than 3 hours. Okay. How are we feeling so far?
Wish I was doing better.
Yeah, I'm sorry. How are we feeling class-wise? I guess I should specify.
I have a question.
Yes.
Okay, so for the mean, for the hours,
Yes.
I still keep trying to figure out why it's not the 2.98 and it's the 3. Because it looks like the 2.98 would come from the sample of the 13 and 24 people that
It
he's
does.
trying to.
Yeah. you are correct. The 2.98 does come from the sample, and I cannot use the sample statistics in my hypothesis.
Okay, all right, thank you.
Yep. Okay. So I know that I skipped over number 2 and number 3, but if you notice on the PowerPoints, there's little YouTube videos embedded into them. Okay, so if you need more practice with them, you can go back and look at those problems. They are written out for you. I am going to show you how to do this one in the calculator so you can follow along with me. So we go to stat and we go to tests. And again, this is a t-test. And we have stats again. And our value from the hypothesis was 3. Our sample mean was 2.98. Our sample standard deviation was 2.66. And our sample size was 1324. And the direction was two-tailed, not equal. Now, the calculator already gives you the answer after they multiply it by 2. So when you're running it through the calculator and through the t-test, you don't have to do anything, okay? So hit enter, and we are going to calculate. And do we get the same answers as what we did by hand? Just a lot faster. Okay. I'm going to show you some examples. So we're going to slide 9 if you're following along with the slides. Okay. We're going to show you how to do this in the calculator. I wrote out the steps for you, so hopefully we can follow along with that as well. A popular charity used 36% of its donations on expenses. An organizer for a rival charity wanted to quickly provide a donor with evidence that the popular charity has expenses that are higher than the other similar charities. The organizer randomly selected 10 similar charities and examined their donations. The percentage of the expenses that those 10 charities spend on expenses is given below. Super tongue twister. Side note about charities. This 36% of its donations on expenses is actually pretty low. If you look into charities and see where the money actually goes, sometimes it's very shocking. So that's just my little connection this to the real world. Sometimes I've looked into charities and seen how much money I've donated to things and whether it's actually gone to the charity that I wanted to go to, or if it's gone to like corporate and the overhead. And a lot of times it goes to corporate and overhead. So just be careful. Sorry, side note. Other side note about this one. This 36%, right? I know I've told you to convert the percent to a decimal, but in this instant, you do not. This is the one time that is the exception-ish to the rule. And the reason that is because the sample is not in decimal form, right? The sample data is the whole percents. So when you work this problem or anything similar to this problem, if you have anything like it in the homework, then you would not convert it to 0.36. You would leave it as 36. We need an HO and we need an HA. In this case, the mean is equal to 36. In the HA, is it less than, greater than, or not equal to?
Less than.
Oh, greater than.
Anybody have not equals in there? Go for the trifecta. So why would someone say less than and why would someone say greater than? Does anybody want to provide their reasoning?
So I see higher than, it says charity expenses that are higher than other similar charities.
Yes, that expenses are higher than other. Okay, so it's going to be greater than. Has the less than changed their mind or they want to defend theirs? Now, if I was going to compute this by hand, right? I would need to come up with the sample mean and the sample standard deviation. Do you remember how to do that?
Don't you add all the numbers together and divide by how many you have?
Right, so that's the mean, right? Yes, so I would divide, for the mean, I would add them all up, right? The sum of x divided by n. Okay, and then do you remember sample standard deviation? The long process, how would I do this on the calculator?
Isn't that taking their values and squaring it? The answer?
Kind of, it's the sum of the values minus the mean squared all over, in this case would be n minus 1. And then you take the square root of it. How do you do it on the calculator? Do you remember how to do it on the calculator?
So you go to data, no, start, edit, and then put in the data, and then wait.
No, you're right. You're on the right track. So here, let's do that first. Let's put our data into into there. Okay. Let's see if I can make it so you can see both and see both clearly. Can you see everything now to put the data in? So we go to stat, edit the list, you make sure that you clear it out. And then we're going to enter in the data. Oh, sorry, you can't see the data anymore. I'm so sorry. I just realized that I didn't have the green around it, but you could see my calculator still to enter it in. So, so that still worked, right? Okay, if I was going to find the mean and the standard deviation, I would go to stat and calculate one variable stats, and it would give me the mean and the SX, right? But I'm already using the calculator to find those, to then go do it by hand, to then go do the other thing. Let's bypass all of that. And we're just going to go from stat, and we're going to go to tests. We're going to go to the t-test. And this time we're going to highlight data. Our data should already be in L1. The only two things that I need to change on this are the mu0 or the null hypothesis, and in this case it's 36. And I need to change the direction of the inequality to be greater than. The mean, the sample mean, the sample standard deviation, and the sample size will all come from the data that I entered in. Okay, it will run everything else for us. We go down to calculate and we hit enter. And this is what you get. If I entered everything incorrectly. Did anybody get anything different than this? Oh no. Did I do something different? Okay. Never mind, I messed up with something. I'm sorry. Go back to the original, please. The less than person was correct when they said it earlier because it says it specifically in the bottom of the problem. So this is my fault for not going further. So I should have keep going with that. Which changes this up here. There we go. This should be the correct answer that you have. Sorry about that. I didn't read on further to look at all of it, and someone else already had. So I apologize. I think it was Carnicia said a less than originally. So I apologize. At least I know who the person is that says it, and I can admit my mistakes. So when you run this, then you have your t value. Okay, and we need to write that down. I believe that they have it to 2 decimal places. So negative 4.09 would be the t. And the p value for this would be 0.00 if it's to 2 decimal places. I'm going to put the 1 in there just because I like to have a number, but you could put 0 as your answer if it was to 2 decimal places. What do we compare it to?
Zero point zero five.
Yes, 0.05. There is none given, right? But if I was going to continue on and compare it, I would say it's less than. And what would our conclusion be?
Reject.
Yes. Reject HO. There is sufficient evidence to state less than 36%. Any questions besides my folly? Okay, I am going to do breakout rooms because we're going to work on number 10 in your breakout room. Okay. And we're going to have 4 breakout rooms. I'm going to create them. I'm going to have you go to them and you'll have about 5 minutes to work on this problem there. Okay.
Uh,
Is this what you got? Those that are coming back in. Was that enough time to work through the problem with your groups?
Yes,
Too much time or just the right?
just right, because we kind of messed up and had to go back.
Okay, perfect.
Well, I should say I
Okay.
messed up and had to go back.
Oh, no. Half the trouble with this is, we'll see, half the trouble is entering the data, I think. Okay, so we are comparing it to 10 because it's believed to be 10. And we enter our data into the list and we get a T of negative 1.12 and a p-value of 0.2996. If we rounded that to 2 or 3 decimals, it would have been 0.300. We compare it, we fail to reject, there is not sufficient evidence, or they might say there is insufficient evidence. So I wrote that down there as kind of like an extra way that they could possibly write your conclusion. Did anybody not get this as their answer? Okay. I'm going to do one more, which I think is kind of a funny one. I'm going to share the screen. So be careful with this. A Nissan ad read, the average man's IQ is 107. The average brown trout's IQ is 4. So why can't a man catch a brown trout? Suppose you believe that the brown trout's mean IQ is greater than 4. You catch 12 brown trout and a fish psychologist determines that their IQs are 5, 4, 7, 3, 6, 4, 5, 3, 6, 3, 8, 5. Conduct a hypothesis test of your belief. Use an alpha of 0.05. Now, I think this is kind of an outlandish example for t-tests, but hopefully it's one that you remember. I'm going to break you into your groups again, and then I'm going to share this with your groups as well, okay?
oh, sorry for the delay. I must have, sorry.
That's okay. Just go to your group now. You're good. They're still waiting for you, so you can go into your group.
Oh,
That's what people got. Make sure, yeah. Is this what everybody got for their answers?
not at first. I used the 107 instead of 4.
I had a lot of people that in my face-to-face that did the same thing.
That's what I got. Yeah. Yeah,
Okay,
that's all we got, right? Yeah. Yeah. Carrie.
okay. I am gonna show you Newton, just so you can kind of see what it would look like, and kind of see, sometimes they're not gonna be asking you for everything, they're just gonna be asking you for a certain value. So this is an example of what you could have on Newton. And in this case, it just wants the p-value. Okay, so you still need to write the null and alternate hypothesis. You still need to run the test with the data, but the only thing that they want for the answer is the p-value. Okay, I'm going to stop sharing for a second just so I can get to the next problem. Okay, and then I will show you the other ones, what they look like. Okay, so let's do this one together as a class. Joan notices that the set of children's building blocks had different numbers of blocks. The set she wanted to buy had 105 blocks in it. She wanted to know if that was above average, but there were hundreds of sets to choose from. She randomly selected 10 building block sets that cost the same as the one she wanted. Joan conducted a one mean hypothesis at the 5% significance level to test if the average number of blocks in a set contained less than 105 blocks. So which one of these is our correct null and alternate hypothesis and the tail? Is it 1, 2, 3, or 4? You can hold up your fingers if you want to. Okay. Anybody else have fingers and want to write a number down? Okay, I got another finger, another hand. Okay, we're going with number 1. Yes, send us some in the chat. Thank you. So yes, it is left-tailed. Then we would continue on. Now I need to take and enter this data into my calculator to come up with the answer, right? So please try doing that really quickly. And it's 2 decimal places. Did anybody get negative 1.21?
I did.
Okay, and our p-value, we get 0.13 when we round it to 2 decimal places. We are correct, and it tells you how. Now, I need to take my p-value. Let me annotate. Now I need to take my p-value and my significance level and compare them. So 0.13 compared to 0.05. Which one's bigger?
P-value.
That one. So we need to select two answers down here, right? Are we rejecting or fail to reject?
Fail to reject.
Fail to reject, and fail to reject links with this bottom one. Do not provide sufficient evidence. Okay, if I had reject, it would link to this one, the other one, which is it does provide sufficient evidence. Okay, we hit and we're done and we've completed it. Okay,
I have a quick.
yes.
So on that second part of the question, what would I enter into the t-test on my calculator?
You would have had the data entered into the list, right?
Yeah, I already put that in.
And then for your under data, the only thing that you would need to do is the 105. Or the mu that came from the hypothesis.
Mm-hmm.
And then you would go down and you would have the middle one highlighted, less than an alternate hypothesis.
Okay. Okay. All right.
Okay. Things of note, we do have class tomorrow. We don't have it the rest of the week. The discussion board this week is the last discussion board of the semester. It's worth 10 points. So it's beneficial for you to do it because it's worth more. Okay. It's not math related. So I give you a break. And I made it so the discussion board post is not due until Sunday. Okay, because I know that Thanksgiving, some people are going to be busy traveling, doing whatever, sitting at home, not celebrating it, whatever you do during the holidays. Okay, but I did give a thing, so the discussion board is not due till Sunday, and so are the homeworks that we're going over today and tomorrow. So 9.4.5 is what this is, and I will post the notes and the lecture once they become available. Okay, once I can format them and everything. So I'm going to stop recording.